Okay, get ready, because we are going deep today into DMT. Specifically, its pharmacodynamics.
That's right.
Like, how does this crazy psychedelic interact with the brain all the way down to the serotonin receptors?
Absolutely.
Like the 5-HT2A and the sigma-1. So we've got a bunch of research articles here to dig into.
Yeah, we do.
Some focusing on DMT itself.
Right.
Others looking at the whole serotonin system.
Absolutely.
You know, like how psychedelics even work. It's like magic, right? What's really wild to me about DMT is the speed.
Oh, it's fast.
It's like boom.
Like a comet.
Right. It hits those receptors so hard and then vanishes.
A fleeting comet streaking through your brain in the cosmos of your brain.
So different from like LSD or psilocybin.
Yeah, it's a totally different experience.
Yeah, those short trips, right?
Exactly. It's like a flash trip.
The flash trip.
Yeah.
Why is it so short, though?
Well, I mean, compared to...
It's all about the monoamine oxidase.
Okay.
Or MAO.
The MAO.
Yeah, it's an enzyme.
Got it.
And it acts like a cleanup crew in your brain.
Okay.
Breaking down that DMT super fast.
Okay, so that's why it's short.
Yeah.
But, like, what's going on in those few minutes?
Okay, well, to really get that, we got to zoom in
right.
on specific receptors.
Okay.
Let's start with the big one.
Yeah.
5-HT2A.
Okay, the famous 5-HT2A.
Yeah, this is where the 5-HT...
This is where the magic happens.
The main stage for DMT. If the brain is a concert hall...
Oh, I like that.
That's where DMT is playing.
Yeah, headlining.
Headlining
5-HT2A.
DMT is the agonist.
Yes, a potent agonist. And like at the 5-HT2A receptor.
For someone who doesn't know, what does that even mean?
Oh, right. So an agonist is like a key that fits perfectly into a lock.
I got it.
And it activates the receptor. Oh. So when that DMT binds to 5-HT2A, it kicks off a whole chain reaction.
Whoa.
Like dominoes falling.
Interesting.
And one of the key parts of this is GAC-mediated signaling.
All right, keep going.
Which ultimately leads to excitation in the cortex.
Whoa.
Which is the outer layer of the brain.
So it's not just like on-off.
No.
It's a chain reaction.
It's this whole domino effect.
Got it.
Now here's where it gets really interesting.
Okay, I'm ready.
5-HT2A.
Yeah.
It's also been implicated in psychosis.
Wait, what?
Yeah.
So the same receptor?
Same receptor.
That's like giving us this...
Giving you this amazing experience.
Yeah, the psychedelic experience is linked to a mental health condition.
Yes.
So how does that work?
Well, that's the million-dollar question, right?
Yeah.
It seems like a contradiction.
Totally.
But the key might be in DMT's speed.
Oh, interesting.
Yeah, because some scientists think that DMT's rapid action might actually bypass those negative effects.
Psychosis.
So it hits the receptor.
Hits it hard.
Creates this burst of activity.
Yeah.
Gets out of there.
Gets out quick.
Right before things get too crazy.
That's one theory.
Okay, so...
And we still don't know for sure.
Or research needed, of course.
Now, there was this study where they blocked 5-HT2A with an antagonist.
What's that?
Oh, so think of it like a key that fits the lock.
Okay.
But it doesn't turn it.
Oh, interesting.
So it blocks the receptor.
Got it.
And they did this with psilocybin.
Okay.
And it blocked the positive mood effects.
Oh, wow.
Yeah, but whether that applies to DMT with its, quick in and out is still an open question.
Okay, so even though 5-HT2A it's connected to psychedelics.
It is.
And to psychosis.
Yeah.
DMT might be doing something totally different.
Totally unique.
Because of how fast it is.
Exactly.
Okay, cool.
All right, now let's move on. Yeah, let's move on.
To another key player.
Okay.
The sigma-1 receptor.
Okay, sigma-1.
Yeah, this one is a bit more mysterious.
It is, yeah.
Tell me more.
It's like a side stage. Where DMT is doing its own thing.
Okay, so what's happening?
Well, early research suggests that DMT with sigma-1 might be messing with the calcium balance.
Calcium?
Inside the cells.
Oh.
Which is crucial.
So is this like...
For how neurons?
Like in muscles?
No. It's calcium in the brain. It's like a messenger.
Oh, okay.
That helps those neurons talk to each other.
Interesting.
Yeah, there's this hypothesis.
Okay.
That DMT messing with the calcium via sigma-1 could actually protect those neurons from damage.
Whoa.
It's pretty wild, right?
Yeah, so it might be like creating this intense experience, but also protecting the cells.
Or protecting the brain.
That are even causing those experiences. Yeah, it's a really fascinating area.
It's so cool.
But it's early days.
Mm-hmm.
You know, we need more research
Of course.
to really confirm it.
Yeah.
But it adds this whole other layer to the DMT story.
To the story of DMT.
Yeah.
The mystery of DMT.
The mystery continues.
Absolutely.
We can't forget that DMT isn't working alone.
Right.
It's hitting other serotonin receptors too.
Okay.
But we don't really know that much about those.
It makes me think about set and setting.
Oh, yeah.
Right, because if DMT is working on all these receptors, wouldn't your environment
Absolutely
and like your mindset matter?
It matters a lot.
So even though it's these tiny molecules, it's the bigger picture too.
The context is key.
Right, the context. So like someone who takes DMT in nature versus like a city street.
Totally different.
Totally different, right.
One study found that people who took psychedelics in nature, they actually reported less psychopathology.
Wow.
And greater well-being.
That's amazing.
Compared to, you know, urban environments.
Makes sense.
It shows how connected everything is.
Yeah, it really does.
You got the biology, you got the psychology, and the environment.
And the environment all playing together.
Yeah.
It's fascinating how research
I know, right?
is really connecting those dots, like the subjective experience and what's happening in the brain.
Yeah, it's bridging that gap.
Is there any research that really stands out to you?
Yeah, there's this one study by Carbonaro.
Okay.
And it was published back in 2015.
Okay.
And they looked at different serotonin receptors.
Oh, cool.
Especially the 5-HT2A and the 5-HT2C.
Okay.
And they wanted to see how those receptors played into the effects of DMT.
Okay, so which ones were causing those DMT effects?
Exactly. Yeah. And they used mice.
Mice on DMT. Okay.
Yeah. Well, they looked at a behavior called the head twitch response. Which is often linked to psychedelic effects.
Got it.
And they found that when they blocked the 5-HT2A receptor, that head twitch response went way down.
Interesting.
Yeah, so that really points to 5-HT2A as a major player in those classic DMT effects.
The main stage, right.
Yeah, exactly.
We talked about that.
Headlining.
Yeah, the headliner.
But what's interesting is blocking the 5-HT2C didn't really do much.
Oh, interesting.
Yeah, so it seems like
it's not as important.
Not as involved.
Yeah.
It's like we're putting a puzzle together.
I like that, yeah.
Figuring out which pieces are most important for those DMT effects.
It's so cool we can actually study this.
That is amazing.
Like in a lab.
Yeah.
Connecting the molecules to what we see.
Right, the behavior.
Yeah.
Yeah.
Now, we don't have as much research on DMT.
No, we don't.
As, other psychedelics.
Yeah, like psilocybin.
Yeah, psilocybin. But are there any studies that can give us some clues?
Yes. There's this really groundbreaking study from 2012 by Carhart Harris. And they use fMRI to look at the brain.
Brain imaging.
During a psilocybin trip.
So we can see.
We can actually see what's happening in the brain.
In real time.
In real time.
That's so cool.
Now, it wasn't DMT.
Yeah.
But psilocybin and DMT, they both work on the serotonin system.
Yeah.
Especially that 5-HT2A receptor.
Right. So the findings are relevant.
Very relevant.
So what did they find?
Well, one of the big things was decreased activity in the default mode network.
What's that?
Oh, it's this network of brain regions that's active when we're kind of like thinking about ourselves, daydreaming, ruminating.
Okay, so psychedelics are like quieting that down.
Quieting the self-talk, that constant chatter.
So interesting.
And that's been linked to ego dissolution.
Whoa.
Which is this feeling of transcending the boundaries of yourself.
Okay, that makes sense.
Yeah.
Why people describe these like shifts in perspective and feeling connected.
Exactly, feeling interconnected. Now, in addition to that, they also saw increased functional connectivity.
What's that?
So that means different brain regions were talking to each other more than they usually do.
Interesting.
Yeah.
So some areas are quieting down and some are getting chatty.
Yeah, more communication.
Interesting.
And that might be related to the creativity, the insights that people report.
Feeling like
seeing the world in a new way.
Like we're really connecting the dots between what people experience and what's happening in their brain.
The subjective and the objective.
That's amazing.
It's really remarkable.
And one of the most exciting areas of research is using psychedelics as medicine.
It's a whole new world.
Now, I got to admit, when I first heard about this,
I know.
I was like, what?
It seems counterintuitive, right?
Yeah, like using a drug
to
treat something like addiction.
It's a mind bender.
But the research is showing
it is
that it might actually help.
Yeah, it's pretty amazing.
But how does that even work?
Well, psychedelics can really help people look inward.
Okay.
Have these deep insights about themselves.
Okay.
And in therapy,
that
can be super powerful for understanding the root causes of addiction.
So it's not just stopping the drug use.
No, it's about
getting to the core.
the root causes.
Yeah, the emotional pain.
Yeah, the trauma.
The
thought patterns.
Right, that drive the addiction.
Yeah.
And that's where therapy comes in.
Absolutely.
So the therapist
is essential.
can guide them through this whole process.
It's a journey.
Right.
A healing journey.
Yeah. And there are studies showing it works.
There was
one study.
Yeah, from 2014.
With psilocybin.
Yeah, psilocybin-assisted therapy.
Okay.
And it helped people quit smoking.
Wow.
Who had struggled for years.
And what about DMT?
Well, there aren't any DMT studies yet for addiction, but research is happening.
That's great.
Because those psilocybin results are promising.
Right.
It gives us hope.
Yeah, for sure.
That DMT could work too.
What about for other conditions?
Oh, yeah, like
depression.
Depression, anxiety.
Anxiety, yeah.
Right.
There's so much research going on.
Yeah.
Like MAPS.
Okay.
The Multidisciplinary Association for Psychedelic Studies.
MAPS, okay. They're doing a clinical trial with MDMA.
MDMA.
For PTSD.
Yeah, MDMA, another one.
Yeah, another psychedelic with so much potential.
And if it works,
it
could open doors
absolutely
for other psychedelics.
For DMT.
Right. Yeah. What about end of life?
End of life distress.
Yeah.
That's a big one.
Right.
Because people facing death often struggle with
anxiety,
depression, fear.
And
psychedelics could really help navigate those emotions, find peace. Acceptance.
Are there any DMT studies on that?
Not specifically for end-of-life distress.
Okay.
But there are studies with psilocybin showing really promising results.
Yeah.
Like one study found that psilocybin really helped reduce anxiety and depression in cancer patients.
It's amazing.
It is.
That these substances that were
demonized.
Demonized, yeah.
Right. Being explored as medicine.
It's pretty amazing.
It really is.
This deep dive has been so revealing.
We've learned so much
about DMT. From how fast it works.
Yeah.
To all the possibilities for therapy.
It's a powerful molecule.
But there's still so much.
Oh, so
more to learn.
Absolutely.
Where do we go from here? It's like we've got all these tools.
Yeah.
But we don't know how to use them yet.
That's a good way to put it.
Right.
And one tool we need to figure out is receptor subtypes.
Okay. Now.
We talked a lot about 5-HT2A.
Yeah, the famous 5-HT2A.
But it's not just one thing.
Okay, what do you mean?
So imagine a key that opens a specific lock.
Got it.
But there are different versions of that lock.
Okay.
Right, slight variations.
Okay.
Maybe a different shape.
Uh-huh.
An extra groove.
I got it.
Receptor subtypes are kind of like that.
Okay.
They're all part of the same family, like the 5-HT2A family. Oh. But they have these tiny differences.
Oh, interesting.
In their structure. And that changes how they work.
So it's not just one 5-HT2A receptor.
Exactly.
It's a bunch of little different ones.
A whole bunch. Wow. And DMT might like some more than others. Oh, it might bind more strongly to certain subtypes.
And that's part of what makes DMT unique.
Exactly.
It's crazy how complex this is.
It is. The brain is a very complex organ.
Yeah, like trying to map the universe. The more you learn,
the more you realize you don't know.
That's what's so exciting.
It is exciting.
Okay, so...
And speaking of exciting stuff...
Yeah, hit me.
DMT analogs.
What are those?
So basically, scientists are making synthetic versions of DMT.
Oh, wow.
Yeah, they tweak the molecule in very specific ways.
As they're
and it changes how it works in the brain.
So could they make it stronger?
Yeah, they could make it more potent, last longer. Okay. Or even target specific subtypes.
That's amazing.
Yeah, it opens up a lot of possibilities.
It's like...
For research and for therapy.
Yeah, like custom designed... Psychedelic experience.
Tailored to specific needs.
Yeah.
It's incredible. Yeah. Just think about the potential here.
Right, but also...
I've got to be careful.
We have to be responsible.
Yeah,
right.
Wait. Psychedelics are powerful.
Yeah, they're not.
We need to respect them.
Yeah, respect and caution.
Planning.
Running.
understanding the risks, the benefits.
Absolutely.
About balance, yeah.
Right.
Science, ethics, and harm reduction.
All of it.
It's a lot.
Yeah, but it's important.
It is. So
as we wrap up this deep dive,
what
are you thinking about?
I'm just blown away by how complex it all is.
It is complex.
We started with DMT binding, and then it just kept expanding. It's like a rabbit hole.
It is, right?
The biology, the psychology.
The environment's all connected.
And we're just scratching the surface.
We are. There's so much more to learn.
It's amazing.
It is.
DMT is a powerful molecule.
It has so much to teach us.
About ourselves, our brains.
About consciousness.
Yeah, consciousness.
And as research continues,
we're
going to learn even more.
So excited.
It is an exciting time.
So to our listener, keep exploring.
Keep asking questions.
The mysteries of the brain are waiting.
And who knows what we'll find.
Exactly.